Welcome to section 11.2b, everybody. But before we go jumping straight into notes and into examples for how to finish section 11.2, let me go ahead and quickly take you over to your Google Classroom. I think just a few of you guys might not exactly be knowing or keeping track of the different announcements in here. And so there's one thing in particular this morning, which is today's Monday, for me anyway. Google Classroom was having some major issues. So I did a quick post on here. Go ahead and go check this out. Ideas about what if your photos, especially for like homework or test corrections, are not loading. Please go read that and follow the directions and see if you're still having problems, still having issues. Sometimes the answer is just to wait, but sometimes it is to go ahead and email or save to your Google Drive your pictures or your PDFs, however you're saving your homework or your test corrections. Test corrections, make sure you're taking pictures of not only the corrections, but also the test too. But you might need to send it over to like a computer or a laptop to upload because your phone's just not going fast enough. But sometimes it is the network and just too many people around our nation and our world that's using Google Classroom. But we're gonna otherwise just jump into section 11.2b. 11.2a you guys see is posted right here. But you guys need 11.2b in order to be able to finish the homework. Those other last two problems of 17 and 21, and that homework going back to your original Google Classroom, section 11.2 is due by the end of the day on Wednesday. So working on it today, Monday, tomorrow, Tuesday, and then getting it turned in Wednesday, and then Wednesday there will be section 11.2 puzzle time that's going to pop up for you guys to be able to review. Let me go ahead and get over to my whiteboard, but I also have my iPad over there so that we can get into the examples for today. So let's get over here, and here we go. We left off yesterday talking about a single box and whisker plot. Talking about a single box and whisker plot. Remember, the whiskers are these outer edges. Both of those are containing 25% and 25% of the data. We're going to need to remember that today. This inside box is containing 50%. Remember, quartiles are like quarters in a dollar, splitting the data up into fourths. Now, today we're going to start talking about some comparison language, trying to think about what one box and whisker plot says compared to another one. And not just that, before that, because if you notice, this next example has two different box and whisker plots. We're going to talk about comparing those two. Before that, there is one other type of description of a box and whisker plot. So we talked about finding the range, the interquartile range. The range is from beginning to the end, least to greatest, smallest to biggest. Interquartile range is going from this first quartile to the third quartile. How long is that? We saw yesterday it was $9. Or I should say it depends on when you watch the video. In the earlier video, $9 for this example was the interquartile range. The median always marks, remember, median, middle, like middle of the road. So anyway, a lot of vocab. You guys have to be taking notes. I've heard from a couple of you questions where it's like, oh, if you were only taking notes. You need to be taking notes and working out these examples with me. And if I go too fast, that's okay. I'm trying to get you the content in a nice, short, succinct video as far as my tips, my tricks, examples. Pause the video at any point and go ahead and take down your notes the way that you guys need to, okay? That way you can reference them. And I mean, we are going to be having like an assessment coming up, a quiz or a test. And teachers are assuming that you are going to be using like open notes, open books for some of them, depending on some teachers might be recording you guys taking tests. Our test is still a little ways out. We still have a bit more of chapter 11 to cover, but if you're not taking good notes, you're not going to be able to remember what all the things are that we've practiced or that we've done. So please take notes. It'll help you in homework, just like the worksheets were helping in homework, and it'll help you for the test. So here we go, number 4. We're going to start this one in just a second. So if you guys want, you can pause the video now, and you can either take a picture of this or you can get it set up and ready in your notes for us to answer some of these key questions. These are going to be the key questions of today. I'm going to go ahead and go get my highlighter so that we can look at them. Identifying the shape of each distribution. Distribution is what these box and whiskers are called. It's distributing or showing, identifying the data that we've been given. Then the next question is, which one is more spread out? And we'll talk about what that means, being spread out, although some of you are probably like, duh, in this one. But more spread out, and what does that mean? And in context, what does it mean? Because it says explain. And then this last one says, Which state had the single least number of tornadoes? That's another good question. There might be some other ones that show up in homework, though, that I want us to be ready for. One in particular, if I remember right, is, reminding us or asking us about where the data is, where 25%, 50%, 75% is, et cetera. So a quick reminder of that as well. But before we go on, we need to talk about shape. We need to talk about shape. Yesterday, when we were asked about the box and whisker that we were given, they were asking for us to describe, which you would think describing is giving the shape, right? But not always, not necessarily. In this one, when we're looking at the data, when it says describe the distribution, it's just asking us to talk about that 25%, that 50%, and then that other 25% of data, just kind of describing it's a whisker, and then it's the box, and then it's the whisker, and describing where those fall as far as the prices of the soccer balls, about how much data was in between 8.50, 11.25, how much of the soccer ball prices were in between 11.25 and 20.25 as far as $11.25, $20.25. And then that last 25% was on the upper end. So that was how we were describing it yesterday, but we weren't describing at all the shape of it. You might have heard me say in section 11.2a, the idea of symmetric and the box and whiskers having symmetry. Let's peek over into the book right now. If you have the book with you, I think this is found on page 596, but here's a core concept, there are shapes of box and whisker plots, specifically, not just descriptions, but specific shapes of how they can happen or how they can occur. And what I want you guys to see in each of these, or to notice, is which whisker is the longest. Which, remember, cats, dogs, animals, whiskers, right? Which whisker is the longest? It's kind of like if someone was to, sometimes I do like Pilates or yoga, and sometimes you have to like balance on one foot, or if you're doing like a karate chop kick, right? If your leg goes out to one side, usually your body tilts away to the other side. That's kind of what's going on to these ones. That's one way of remembering it. Like if you were to do a karate chop kick, your body leans back, kind of like in this one, the box and whisker is seemingly over to the right, is kind of like heavy on the right. But this one isn't called skewed right, it's called skewed left. You have to think about which way you're kicking or which whisker is the longest. A few different ways of thinking about it. The karate, which way you're kicking to the left, or you can think the whisker is longest to the left. And that's kind of what they say down below in the wording as far as the left whisker is longer, but the interpretation of that, which is kind of helpful for us answering those like those explanation questions. It says most of the data is on the right side of the plot. Just like if I was kicking, most of my weight, most of my body is over here to the right, but I'm kicking left. So skewed left is a little bit weird, but if it's skewed left, most of the data is on the right. And then similarly, skewed right, you're just kicking the other way. So I'm kicking right, but most of my body is over here on the left. Same thing over here with skewed right. Most of the data is on the left-hand side whenever it is skewed right. So then all we're left with is, okay, well, if we have the skewed left where most of the data is on the right, skewed right where most of the data is on the left, then what other type of shape is there? And this is that symmetric shape. So here's one way of remembering it. And the book kind of tends to outline it. Remember, they give these really cool, if you've ever used your book to study, these cool study tips over here to the right. But symmetric, one way of thinking about it is yesterday we were using blue a lot for the median, right? The median, the middle. If that median is in the middle of the plot, that's one key indicator that it's symmetric. Another way is just look at the whiskers. If the whiskers are the same length, we can also call it symmetric. And the nice thing is it says about the same length. So we don't necessarily have to get our rulers out or totally check everything to do with the number line. We'll call it at least roughly symmetric if they seem to be about the same. There isn't an obvious whisker that's bigger than the other one. So we just say the data is symmetric. So that would be our first answer to this first question in this problem that we were going to tackle together. In this one, we're talking about number of tornadoes per month for a year for 2 different states. They didn't tell us what the 2 states are. Maybe if you've seen Wizard of Oz, you might think one of them's Kansas. But my sister lives in Ohio, and they get tornadoes too sometimes, or Indiana. But state A and state B, we're just comparing the tornadoes. Now, If we're just talking about the shape, remember when we go through and answer these, we're gonna have to be talking about both of the distributions. And letter A, we're just gonna talk about them separately. So we have state A's shape and we have state B's shape. State A's, if you guys are looking at this one, remember, compare the sides, compare the whiskers, and ask yourself, does one seem to be longer than the other? Now, in the bottom one, hopefully you guys are like, okay, yeah, I totally see it. That one's way longer, right? If that one's way longer, remember the way that the side that the whisker is longest, or the way that you're kicking out and you're leaning the other direction, that's the type of skew. So for the B, for state B, I can say it's skewed right, because that right hand whisker is longer. Skewed right because that right hand whisker is longer. I'm double checking because even I get this one confused. But when we look at the other one, check out the two whiskers. You could come down, and if you really, really wanted to, you could see this one starts at 0 and seems to end around 4. So this whisker seems about 4 long. This one starts at 10, ends at 14, seems about 4 long. But we can also maybe just look at it and say, you know what, they seem to be about the same length. You can also remember that little trick is to ask yourself where the median is. That median seems to be kind of in the middle of that box and whisker plot. So then looking at the whisker sizes, looking at the median, yeah, that A1 is going to be what we call symmetric. And remember symmetry, we talked about that earlier this year, kind of like the butterfly that can fold and then open. We had symmetry across like the y-axis or across the x-axis. This one, the box and whisker plot, is symmetric on either side of the median, at least roughly, but it looks to be pretty stinking symmetric. So those are the shapes for each of the distribution. One of them is skewed right and one of them is symmetric. Now, I didn't say to explain, but if we needed to, remember the skewed right one means most of the data is down here on the left. And then the symmetric one means they're about even as far as 50% here and 50% there. Or I don't know exactly. I know this entire box is 50% and that's 25. It's a little bit harder as far as asking ourselves exactly where the data is. Well, maybe it's not all that bad. Because if you remember, the median is actually a quartile also. So then maybe we can say 50%, 50%. But when you look down here, 50% is way down low in this one. Then the other 50% is way more spread out. Now hold on, what's letter B's question? Which state's tornadoes are more spread out? Now if we needed to, once again, like I showed you yesterday, some of these examples in the book are really good as far as giving us how to answer certain questions that are asked. Like if you guys look at this one, this example number 3 in comparing box and whisker plots, if you look really closely at the terminology, it's going to look so similar about the shape of the distribution, which one is more spread out, why it's spread out. And this one, if you guys just went with your gut, your intuition, wouldn't you say the Friends class was more spread out? But what would your reasoning be? Would your reasoning be that the box and whisker is longer? Would your reasoning be that the range, if you want to use your new vocabulary, the range from the lowest test score, that's what's going on in this one, to the highest test score is bigger or is longer? Would your reasoning be that the range, the interquartile range is longer? There's a lot of different ways that you guys could have explained it. If we're to look at the books and how they explain it, just for one example, they specifically use some of those words that I was just using a second ago, like talking about the range, like talking about the interquartile range. Remember this range, I'm going to go ahead and go get a green pen just because that's what we used for the least and the greatest yesterday. A little hard to see that green pen, I'm sorry. The coloring is a little bit off because of the webcam trying to see the iPad, but this is green. So the range from the very lowest to the very highest, that one is longer in the Friends class than in your class. And then the interquartile range, that one I probably shouldn't use green. I think we were using red for those quartiles yesterday with blue being the median. The interquartile range, how big or how long the box is also longer. So yeah, that's totally sufficient. Now maybe you could have used or would have used different wordings, but this is how to start implementing and kind of applying that new vocabulary that we so then the final conclusion is because those two are greater than or longer than the matching ones in your class, then of course the test scores in your Friends class are more spread out. So most of your guts were probably exactly right if you were to answer this without us even looking at that example. Which state's tornadoes are more spread out? Well, sure looks like state B is a lot more spread out. But if we wanted to actually give good explanations for that, since we know what the answer is, we can go ahead and start with that. There's two different ways of explaining. One way is to start with the explanation and give your evidence and then make your conclusion. If you were in an English class, that might be something like writing your essay, your body paragraphs, and kind of leading towards a certain conclusion, and then bam, you hit the conclusion paragraph with really powerful statements kind of showing like, I have proven this to be true. So one way is to start with the evidence and end with a conclusion. The other way is to start with what you know to be true and then explain why. So the book did it one way, I'm just showing how to do it the other way. The other way is state B is more spread out, and I'm going to say since, or you could also say because. Now we have to actually give a reason why. And you can do a couple different things if you want to talk about how the number of tornadoes, the lowest it goes is 4 per month and the highest it goes is 27 per month, which is way more spread out than this guy who only has 0 to 14. You could talk about that and using the word spread. But since spread is part of it as a part of our answer, we don't necessarily want to use it in our explanation also. It's a little bit of circular reasoning. And so instead, maybe using that vocab word of range, since the ranges, and there are technically 2 different ranges, but it's going to get a little confusing because if you just use the word range of your data, you're specifically talking about lowest to highest. So let's go ahead and try to, in our mind, separate those 2 vocabulary words. So the range of the data is much longer. You can say larger, you can say greater than state A's. And so is the, if you want to talk about the actual box itself, remember, then we have to use that other term, the inner quartile range. So different ways of wording it, but you can totally, once again, use those 2 main vocabulary words of range and inner quartile range to help you kind of explain what's going on. Yes, I know that you can probably look at it and say, hey, look, it's more spread out, got it. But if we're using that vocab, the ranges are larger, the ranges are greater in the data itself. So that was a pretty easy one to ask, then, or to answer. In letter C, it says, okay, wait a minute, we didn't highlight this one, so what's going on with this one? Which state had the single least number of tornadoes? The single least number of tornadoes. They're not saying which one is lowest necessarily. They're not saying which one has the shortest or the narrowest range, etc. They're specifically talking about the single least. So even though this one has, or it seems to have, a much wider spread, it still only goes down to 4, whereas state A goes all the way down to 0. I think I said just a second ago, we're not looking for which one is the lowest. Technically we are. Technically we are the single least number of tornadoes. You're just asking yourself which state, regardless of how the data is, remember, new vocab, distributed, regardless of how it's spread out, which state has the single lowest. Well, remember from yesterday, I'm getting my green pen, even though it's hard to see. The lowest is just this guy over here on the far left, and which one is more left, which one is lower? State A is, of course. And our justification would be really easy because state A has the lowest single number. Since, remember, giving that explanation because we do have that explain word here at the end again. Since we could say its least number of tornadoes is 0, whereas state B's is 4. And that's just basically explaining that we know how to read a box and whisker plot, that we can look at this and say, hey, the lowest state B's ever had is 4, or at least in this particular 1 year that they're measuring. But state A had a month where they didn't have any. And they might have had multiple months. I'm just going ahead and remember it could be like 0, 0, 2, 2, 4, 7, 8, 8, 8 from yesterday's homework or 11.2a's homework. Some of these might be repeated, but the point is the lowest it goes is 0, whereas the lowest this one goes is 4. That wasn't too bad. And it's really similar to basically, you guys only have 2 homework questions from or with this type of comparison language and this type of like, hey, let's explain the shape of the box and whisker plots as far as being skewed left or right or symmetric. But I did see one thing that might be a little bit tricky in your guys' homework problems. You have 2 separate ones. One of them is number 17. And one of them is number 21 over here. Number 17, if we look at it really fast, real quick, the shape, oh, we get that. Spread out, oh, we get that. Single worst, oh, that sounds kind of like what we just did. But number 21, shape, okay. Oh, these questions change a lot in number 21. I just wanted to give you guys a heads up. You're still using the box and whisker plot, and you're technically, remember, this is the end of section 11.2. You might be using some of that vocab from 11.2a. And so keep a really close eye on the vocab that they're asking, like what is the range? Okay, hold on, range is subtracting a higher minus a lower. Range, we can find the range of the whole piece of data by subtracting where the far left is from the far right of each of these data. But it's not asking for the range of 100% of the data. That's what this range is. It's the range of all of the data, the very lowest to the very highest. They're saying what is the range of the upper 75% of each brand. Now you might have to go back to what the box and whisker plots are from maybe yesterday to be like, wait a minute, 75%, I'm a little bit confused as to where that 75% is. But if you remember really quickly, just because it might help you on these types, in each whisker, remember there's 25% of data in each whisker. And then we normally say in each box, there's 50% of the data, which we're true, we're right. But remember, quartiles cut it into fourths. So even though this whole box has 50%, the median is not truly in the middle of the box. The median is that second quartile. So if I have this one being the far left, this one marking 1/4, I have to go all the way over here to mark the other fourth, and then I'm done. Which means if it helps, which I think it will, even though the whole box is 50%, well, 25% is going to be before the median, and 25% is going to be after. So if they want the upper, I'm going to do it with my laser pointer so that way I don't totally give it away. If they're asking for the upper 75%, maybe this is the data that you guys need to find the range of. Remember, range is just subtracting the higher minus the lower, at least specifically when we're talking about the data. So I thought that might be helpful for you guys to go ahead and review what's going on as far as where the data is and what percentage of the data is in each part or each piece of our box and whisker plot. We do have a couple other questions about interquartile ranges, which technically just review your vocab from yesterday. Which brand has a greater, standard deviation. You might have to peek back at your notes that you're supposed to be taking from section 11.1 to see if you guys can figure out standard deviation. Standard deviation, doesn't that have to do by how the data differs from each other? Differs, Deviation, deviate, to change. I wonder if that has something to do with being spread out. Anyway, think about that one. And then letter E has to do with if you need a cell phone battery that has, or a cell phone that has a battery life of more than 3.5 hours. Well, just kind of think about the data and say, well, which one seems to be the better brand? All right. So as you guys are thinking through homework, you're just finishing number 17 and 21. And then you are submitting the entire thing by Wednesday. Technically anytime Wednesday, but the sooner the better, because there is going to be a section 11.2 puzzle time that comes up, I believe, Tuesday night, I believe, and that's due Thursday. So just keep an eye on those deadlines, kiddos. Hopefully it's helpful in that it's all nice and in there in the assignments category. And as always, online math labs. Today there was a math department meeting. I'm supposed to put it in there if you have questions. Come in tomorrow or the next day, Monday through Thursday. You guys have, I think, from 8:55 or maybe it's 9. You guys have your online Zoom session. Just go check out the details in Google Classroom, and I will catch you guys when you come by and visit me there. So hope you guys are doing well. Hope you guys are staying safe, not going crazy, having to stay inside. Go take a walk outside. Just watch that social distancing, and please reach out if there's anything that I can do to help. And otherwise, I will talk to you guys later.